Hey, good morning, and welcome back to another class. Today we are going to be discussing weather phenomena that you could experience in flight. So I just want to start off by reminding everyone to please go to the attendance page and selecting the attendance form and filling it out with your last name first so you get credit for being here. Alright, anyway, that being so we're going to talk about first is we're going to talk about dew and frost. So as we look and we have our parcel of air that is filled with gas, and then our air temperature changes and hits that dew point, is that we get moisture and that will condense because the water is saturated, and then dew is whenever that condensation happens low to the ground. You can usually see it early in the mornings when the temperature is generally at its coldest before the sun starts to rise, and you'll notice all the water droplets forming on, say, a car or your grass in your yard. So dew is just visible water droplets. If when that water condenses, the temperature of the air is below freezing when that water hits its saturation point, the water can still form on grass or whatever surface, but it will instantly freeze, and that is how you get frost. For those of you that do have your license, if you remember early in December and January, when you would go outside, you would notice that there would be a nice layer of ice on the windshield of your car, and you would have to clean it off so you could be able to see. That was frost. The next thing we're going to talk about is we're going to talk about fog. And what is fog? Fog is basically a low-lying cloud next to the surface of the earth. And we're going to talk about the different ways that fog can form. And we're going to talk about the hazards that fog presents to somebody. So what fog is as the air that's filled with water vapor reaches its saturation point, it has to do with the temperature of the ground. So the primary type of fog that we run into being inland in Florida is what's known as radiation fog. And what that is we have this saturated air, and then the ground beneath it, it cools at a much higher rate. So what happens is the ground will cool, and then it will drop the temperature of the surrounding air, and then you will get a cloud that develops over the ground. Radiation fog is when there is no air and it is a calm, cool night, and that cloud layer of fog forms over time, and then there is no wind to move the fog. So that is the most common type of fog. You'll usually see it develop over a large flat surface such as a field. The next type of fog we're going to talk about is something called upslope fog, which is something we do not generally have to worry about being on the East Coast. But what upslope fog is is when you have, say, a valley next to a mountain, and the air in that valley is cool, and it takes a stable mass of air and pushes it up a mountain. It rapidly cools it, and the water vapor condenses, and then you have fog up the side of a mountain. Now, the difference between radiation fog and upslope fog is to have upslope fog, there has to be wind present blowing that air up that mountain, so that fog can actually rise a lot higher than radiation fog, which generally stays on the ground. The next type of fog we're going to talk about is known as steam fog, and that is based on the difference of the air temperature and the water temperature below it, which causes the water to evaporate. And then you get fog that just seems to sit over a body of water. You can have it over lakes, rivers, or even the ocean if the conditions are right. And the last type of fog we're going to talk about is called ice fog, which generally happens more northern in the wintertime when the air is extremely cold. So what happens is the temperature of the water reaches that critical dew point, and it forms lower on the ground and creates fog, but the air is so cold it actually causes the fog to the water to instantly freeze, and that is what we call ice fog. So now what we're going to talk about is we're going to talk about those big giant puffy things that you see flying overhead all the time that are white and they look kind of like marshmallows. We're going to talk about clouds. What clouds are is they are used as a visual indicator of weather that is to come. There are a lot of different types of clouds, so we come up with a system to classify them. We actually classify clouds by the height that they are above the earth. We classify them by their shape, whether they're little tiny stringy clouds or they're those big giant poofy cumulus clouds, and we classify them by their characteristics, whether they're going to produce snow or produce light rain, or whether they're going to be cumulonimbus and produce a thunderstorm. So what I want you to do is take a moment and turn in the book to page 12-16, and there is a chart where you can see the different types of clouds. I'm only going to cover a couple right now, but you can see the rest on the chart. You can see that a cumulonimbus, which is another word for a thundercloud, is the largest, and they can go all the way up to 40,000 feet plus sometimes. You can see a towering cumulus cloud, which is a cloud with vertical extensive development. You can see we have stratus clouds and the light wispy cirrus clouds. So please take a minute to look at those on your own to start learning about the different types of clouds we have. So now we're going to, now that we've talked about clouds just for a minute, now we're going to get into types of weather that can be potentially hazardous to pilots. As we get into learning how to look at different weather systems, we're going to talk about something that is known as a ceiling. And the two types of ceilings we're going to talk about is we're going to talk about a broken layer of clouds and an overcast layer of clouds. So, what a cloud layer is, it is considered the layer that whenever you look up into the sky, you cannot see through it. So, if that cloud layer covers 5/8 to 7/8 of sky, we call that layer of clouds broken. You will not generally have to know how much sky is covering because weather information centers will tell you. So if it covers 5 to 7/8, it is considered broken. And if the sky is fully covered by a layer of clouds, we call that an overcast layer of clouds. These are both important because each type of cloud produces different types of characteristics in flight, whether it be turbulence or rain or other hazards that pilots need to look out for to be safe. So now that we understand that what cloud layers can be, we're going to talk about something that's extremely important when it comes to taking off and landing, and that's called our visibility. So we have established that we can look up and see a layer of clouds at a certain altitude, so that's looking up vertically. But visibility is defined as being able to look horizontally and find out how far you can see. When we go into airspace, you will find out to fly through different types of airspace are visual requirements. So how do we know what we can see? Well, that is usually taken care of by our in-flight briefing. But when it comes to visibility, you should be able to see a certain amount of distance. So if we were to fly instrument flight rules at a towered airport, like a large airport like Atlanta, they actually use something called an RVR, which is a type of laser, and they can actually shoot that laser, and when the light refracts, they will know how far away the visibility is. We call an RVR is a runway visual range. We will go further into depth about how that works later, but what you should understand is that visibility can affect pilots in many different ways. Primarily on takeoffs, landings, and while flying, it can affect the ability to see other traffic. So on takeoff, visibility is hazardous because you may not be able to see when a runway ends or what type of obstacles are around that runway, such as trees, mountains. And the same can be said on landing. There are requirements to be able to see certain distances on landing because you want to be able to see the hazards surrounding an airport and see the runway clearly. The main way to find out about visibility is on a pre-flight weather briefing, which we will cover later. Now, the last thing we're going to talk about today is precipitation. So we know that we have those giant cumulonimbus clouds. So to be considered precipitation, that water has to condense and actually fall all the way to the ground. And that's usually when we call it rain. But so any type of water that comes out of a cloud and falls to the ground, whether it be rain, drizzle, ice, hail, snow. Those are all different types of precipitation. You can get multiple types of precipitation. For example, if the clouds are really high and it starts raining, but they fly through a different air mass on the way down, which can supercool the water droplets, that is an indicator that there is a temperature inversion. We are most concerned about these types, about precipitation, because when it begins to rain, it can actually affect the ceiling and the visibility and create hazards on takeoffs and landings. So that is our short little video lesson today. So please read pages 12-15 through 12-17 to get a further look and answer the assignment, and email me if you have any questions, and we can do more one-on-one if you need it. Have a good day.